Hello guys and welcome. Now today we're going to make a heat shield and we're going to make it with the sheet metal environment because I want to show you a cool little option in the Flange command that I don't think most people are aware of what exactly it does or why exactly it is useful, and I think it's a great little addition to your toolbox. Now before that, because I'm a contemporary man and I follow the times, right, I heard that Ghibli art is really popular these days. So here's some Ghibli art from me. With that out of the way, let's start a new sheet metal part. And for starters, I want to show you the shape that I'm after, right? So I'm going to start with a circle here, 120 millimeters, and I'm just going to convert it to a reference figure. And let's get a line going here. And okay, thank you. And a center arc. So this is roughly what I want to do. Right, we'll make these two horizontal, and then we'll make these two horizontal, thereby making them symmetric. And then I'll just get this going through that center. Let's say that this opening is 20 millimeters, and let's say that, oh, sorry for that this other circle, you see it's not a full circle, it's giving me a radius. I hold shift and move it a bit and I get a diameter dimension. Let's say that this is 160, sorry, which then in turn means that this line is 20 millimeters in length, right? So this is the rough shape I want to end up with. I want a couple of legs that also curve and go on there, and you can bolt it down, right? But I also need a bit of guide geometry, and I'll show you what I mean, right? I'll make an arc here. I'm doing all of this because I want to be able to take an angle. I'll make this equal to the minimum bend radius. Okay. And this can be a reference. Sorry. This can be a reference geometry. And these can be reference geometries too. So what I want actually is this angle. You see, it's not exactly 90 degrees. And I'll make that a parameter so I can use that. Right? Now, sure enough, if I try and make a contour flange out of this, it doesn't like it. So what I'm going to do, I'm going to lift this up, you know, as a visual aid, if you like. And I'm going to project this first line in. I can do that because my sketches are toggled on. And now I'll make a contour flange. I want to make that 300 millimeters. And I want my material to be on the inside of my circle. So there you go, inside of my circle. So I'll start off with this. Now, if I make a flange here, you'll see that I'm getting this angle here, this bend angle, and it's heading off to that direction. That's not what I want. I want it to go all the way around. And I know that this circle has a radius of 80 millimeters. But if I go and make this D8, even if I divide it by 2 to get the actual radius, look what's going on here. It's flying off to a completely different direction. That's not what I want, right? So I'll just bring that back. So how do I do it, right? Well, first of all, I want it to be aligned towards the inside. So the way I do it is I don't make this flange. I click here in the bend only option, which is the option I want to show you today, right? Bend only. And you know, 90 degrees. Yeah, I don't want 90 degrees. I want the value that I got the driven value for. So I want A2. So that's the angle that I want. Okay, well, what did we achieve here? Well, let's make a second flange on the inside again. Bend only is still selected, right? The angle we can talk about later. Let's look at it at this side. Now, if I change this, and it was D8 divided by 2, look what's going to happen. Look at that. It follows it pretty closely, and it goes around this circle. Now, about the angle, well, I've got a 20-degree angle opening here, so if I say 340, look, it comes very close, right? You can see that it's coming really close, and that's pretty cool, right? Now, it's not following this circle precisely, and I'm not exactly sure how to make it follow that circle precisely. I've noticed that if I subtract half the thickness, it'll bring it in closer. But again, you can see it's not perfect. Plus, this extends past this line. So how do we get that back? Well, we get that back by subtracting an angle here that's equal to the angle of a chord that has the length of twice the thickness. So we subtract, let's go into the equation editor, because that's a bit more comfortable. So we subtract that chord, and the angle of a chord is the inverse sine of the chord length divided by the diameter. Is that right? It's twice the inverse sine of that. I'll put the equation up on screen. So let's go ahead and prepare that equation. So we want twice the thickness. Yeah, well, divided by D8. Okay, now this is going to be pretty close. Okay, if you look closely, I put the minus sign twice there. That's why it's adding. It only needs it once, and this should make more sense. Okay. Again, not perfect. I don't know why, but there you go. And now I can hit apply. Okay, so right, it's definitely usable in terms of a heat shield. So I'll make another flange here. Now I just want this to go back to the original bend radius, and I just need this to go back to 90 degrees. There you go. I've got my other bend, and I think it doesn't cooperate very well, but again, this is a part that I don't know another way to make it, and I don't need it to be 100% accurate. But anyway, here's another cool tip. First of all, let me show you that this can actually flat pattern, right? No problem whatsoever. It creates the flat pattern. It's all well and good. Now, I want to get another leg that stops at the exact same point as this one does. So what I'm going to do is I'm going to do my imprinting trick, which I show in another video of mine. And I'll just make a angled rectangle here. And I'll make this point and this point horizontal. Now this is fully defined, even though it doesn't have a single dimension. And I will extrude up to this face. Come on, up to this face, right? Now, this is an extrusion, right? This is not a sheet metal tool. This is the normal extrusion that we all know and love, but you can still flat pattern it and it still works, right? Which is great. And now I'll go and make the legs, and I will do it with the same basic principle that I've done everything else here. So now I'm going to make yet another flange like this, but now this radius is going to be the radius of the inner circle, right? And of course I don't need 90 degrees of that. That's too much. Let's do 15 degrees. Yeah, let's do 20 degrees. It's fine. Cool. And we'll do the same thing on the other side. Let's have nothing selected. There you go. Now only global bend radius, and this is 90 degrees. There you go. Oh, wait. We need to go back into this one and make sure it's aligned inwards. Okay, that's a lot better. And this is useless now, and this aligned inside. Now we're going to make this one. Yeah, well, you see now Same thing here. It needs to be on the outside. But again, these are not super critical dimensions, and I think it works well either way. So now it doesn't want to cooperate. Oh yeah, well, okay, this is fine. Let's go back into sketch 1, and I'll turn this into a sketch as well. That way we can see how far off we are on both occasions, right? So this is it. I mean, so for a part like this is nothing like that a little bolting down is not going to cure. However, if you guys know how I can get it to follow these diameters perfectly, I would love for you to tell me down in the comments or in the forums. I'll also be making a tutorial thread for this. And yeah, I'd love to know how to make it be perfect. But we've got some more work to do, okay? So this is our heat shield till now. It can still be flattened, which is great, because what I'm going to do now is I'm going to select this as a flat face and then select every other bend and unbend it. And unbending it just gives me the opportunity to create some features, whatever I like, and then bend it back up. And these features are going to bend along with the rest of my part. So what I'm going to do is I've got this plane that's right in the middle. I'm going to make another plane in the middle of this edge. And I'm going to use the method I show in my video, how to make a mid plane from an edge. And it's done. Okay, it's one of my earliest videos actually on Alibre. It's in my original tips and tricks series. Okay, so what I'm going to do now is I'm going to sketch here. I will be doing some imprinting and I'll give it, well, let's do a straight slot. So these, I'll say that I want M6 screws, right? So 6.5 radius. Okay, so that's a bit large. Oh, okay, let's do M8 screws then. Wow, got plenty of room. Okay, so we want this to be in the center of this area. Midpoint constraint with 3 points, again, shown it plenty of times in my videos. And I'll just make that 25 millimeters from the edge. Now, this is an 8.5 millimeter clearance slot. So the value of this dotted inner line is the amount of tolerance I will have on the bolt hole when I put the bolt in. So if I say that this is 1 millimeter, I've got 1 millimeter of play to wiggle the bolt left to right, right? I'll just give it like 3 millimeters here, should be fine. And now I'm going to make a hole. That was a cut with a tie tab move. I've shown this plenty of times in my competition, Too Tall Toby competition videos and explainers and React videos and all that. So that's how I cut this. And now I'm going to mirror this feature along this plane. There you go. And then I'll mirror again this feature and its mirror along the new plane. So my bolt holes are done, but for a heat shield to work, you need holes there so that you can get some airflow moving through it, right? That's what kind of cools it down and shields you from the heat. So I'll need this length as a parameter, and I'm going to be using the equation for my linear patterns, my linear fill pattern equation. Again, that's in another video. And I'll just make a slot here. And I'm kind of going for beauty now, right? Right, so let's say that this is 20 millimeters. Let's make it 15 millimeters. And let's make this length 30. So this entire thing should be 45, right? And I'll say that this is 20 millimeters from the, 10 millimeters from the edge. No. 15 millimeters from the edge. I'll also say that in this case, it's always 2 for me. So there you go, it was 2. Let's make that 20 millimeters. Yeah, that's fine. So now what I need is I need the total length, which is the sum of these two values. I need this length, which I have. I need this length, which is the value in my contour flange, right? That 300. And I need the distances from the edges. Okay, so I'll just make this cut and proceed to the linear pattern. So one of my paths is going to go that way. The other one is going to go that way. I want to know that which variable this is. This is C9. I'll go for 7 times. Now for the spacing, C9, which we just checked, times the total length. Now the total length is my contour flange value, which should be somewhere here. Contour flange 1, it should be a value of 300, so it's D11. So this is D11 minus the width of the feature that I am patterning, and that is 15. This is this D178 minus twice the distance from the edge, and that was 15. So twice the distance from the edge, D180. And then I'll divide this with C9 squared minus C9. So let's do that. Okay, change direction maybe. Yes, so I forgot to put this exponent there. So now it's C9 to the power of minus C9. So I just need to put a 2 there, and this will work. Okay. Change direction. There you go. This worked. Now, the reason I do this is because I can change the number of instances and it will distribute them, right? So now I'll say that I want 7 instances going down. This is C10. So now we're going to do the same thing over here. C10 times, I open my parenthesis, and I want my driven value, which is D177 minus. So now the length of the feature I want to do is D178 plus D179, and I need another parenthesis going in here so that the signs don't get messed up. So minus twice the distance from the edge was 20 in this case, which is D181, and I divide it now by C squared correctly this time. There you go. This looks like it's gonna work. There you go. And we can add instances here. 10 is a bit much, isn't it? And that's it, guys. We have made our heat shield, and all I need to do is rebend, select all unbent bends, and click OK. Let's check this out. Oh, this is cool, man. This is a cool looking part. It is. Check this out. Right? We've got our bolt holes slightly slotted, and got them on the other side as well. And we've got the cutouts for the air to go through. And this is a beautiful part, right? It really is. It's a beautiful piece. And the beauty of it is it still has a flat pattern, right? You can still get a annotated flat pattern on how to make this, right? Which I think is awesome. So that's how you make a heat shield, guys. I hope you liked it. If you did, please hit the like button, subscribe for more videos like this, and I hope I see you in the next one.